Dronet is a residual convolutional network that can safely fly a drone through the streets of a city. Dronet learns to fly by imitating the behavior of cars and bicycles, which know the traffic rules and can promptly react to dangerous situations, such as sudden occlusions of bikers or pedestrians. Dronet is able to follow basic traffic rules, as for example not crossing into the oncoming lane, and safely avoiding other pedestrians and obstacles.
Wow!
Interestingly, the learned policy generalizes very well at high altitude. Dronet generalizes also to indoor corridors, even though no indoor training data was provided. In addition, the policy generalizes to indoor parking lots. Recall that no training data from indoor environments was deployed. Dronet predicts a steering angle and a collision probability from a single 200 by 200 frame in grayscale. The shared part of the architecture consists of a fast ResNet 8 with 3 residual blocks, followed by dropout and ReLU nonlinearity. The network branches into 2 separated, fully connected layers, one to predict the steering angle and the other one to infer the collision probability. The 2 predictions are jointly learned from 2 different datasets. We use the publicly available Udacity dataset to learn steering angles. It provides several hours of video recorded from a car. Additionally, we record an outdoor dataset to learn the probability of collision by riding a bicycle in the streets of Zurich. In this set of experiments, we show the steering angle and the collision probability predicted by the network. This testing dataset was collected with a GoPro camera, which was mounted on a bicycle.